This meeting is being recorded.
In problem 10, we're given some information regarding the distillation process of crude oil. And in this specific boiling point range, we produce something called kerosene. And you're given some uses of this type of compound or this product, kerosene. And then we're told that the composition of kerosene that has been patented has these different compounds identified. So these 4 compounds, all of which would be within kerosene, we are now asked to name. So let's take a look here. We're going to use the same process as we've seen before, where we identify our parent. So let's start here, and we'll count all our carbons in our parent chain. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the parent here would be an decane, right, from our nomenclature list. So we have our parent, and then we see some substituents. So carbon 1, carbon 2. We have 2 methyl groups. So we would call this specifically a 2,2-dimethyl undecane. So that is the name for our first structure here. Let's take a look at B. So I'm starting at this end. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then 1 substituent. So I have a decane parent now with 12 carbons, and that 1 substituent, I want that to be numbered at the lowest location. So I'm actually going to number starting at this end. So that will be on carbon 2. So I'm going to call this a 2-methyl. And it's all one word here, 2-methyl dodecane. For our next structure now, we want to find our longest carbon chain. So 1, 2, 3, 4, 5, 6, 7, 8. So I have a octane parent. And then I have 2 substituents on 1, 2, my carbon 2. So I would call this a 2,2-dimethyl octane. And last, in kerosene, we see the structure here is our parent. So we have a cyclohexane parent. And then the substituent is going to be starting here, 1, 2, 3, 4 carbon. So this will be a butyl cyclohexane, and we do not have to give a locant because it's assumed that this is carbon 1 from our nomenclature. Since there are no other substituents, we can just call it simply butyl cyclohexane.